Hello, and here is our class problems for chapters 3 and 4. So I'm going to go through each of these problems here and work out the problems for you. Once again, I'm going to try to keep this video, this one's going to probably go over the first 8 problems, and then the following videos will follow the rest of them. So let's get started. So number 1 question asks, which of the following best describes a distribution with fat tails? So we're talking about distributions and how they look. And A asks, is it a distribution with high kurtosis? B, is it a leptochiric distribution? C, a platychiric distribution? Or D, a bimodal distribution? And so if we want fat tails, as shown here, always think of fat tails, and we're going to think of a platypus, right? Anytime you see fat tails, at the very end, you're going to think of a platypus, which is going to be a platychiric distribution. That's a great way to remember that one. When the mean and median are equal, what can be said about the shape of the distribution? Well, if the mean and median are equal, as you read through all these, you're going to pick answer D. When the mean and median are equal, the shape of the distribution is assumed relatively symmetrical, right? It's not leaning to one side to the left or right. There's no skew this way or skew that way. It's said to be relatively equal, and that's because the mean and median are equal to each other. Moving on, so which of the following is not included in the 5-point summary? You have mode, median, first quartile, third quartile, maximum, and the answer should just point out to you it's mode. We don't have mode in the 5-point summary. We just have our quartiles, our median, maximum, and the minimum. Which of the following statistic is most resistant to the inclusion of outliers in the data set? So this is most resistant. So resistant meaning, what is, it doesn't matter how the data set looks, it's to the inclusion of outliers in the data set. So if you have a bunch of numbers and you have one huge number as an outlier in a data set, what type of statistic is going to be most resistant to it, where it's not going to affect it that most? And your answers are either mean, median, variance, or standard deviation. Well, mean is used to calculate variance and standard deviation, which are going to include the outliers, and it's going to drastically change it. The one that is most resistant to outliers is the median, right? Because the median is just that very middle number. Doesn't matter how big or really small an outlier could be, the median is going to be just that very middle value there. So it's going to be the most resistant to the inclusion of outliers. Number 5, so as the following table of observations represents the performance on the generic depression scale, GDS, based on a sample of patients at a psychiatric office. Calculate the mean, median, and mode for the data set. So one thing you should always just get accustomed to doing when you see data sets or a table presented, especially if it's in like A, B, C, D, E, F, G format, is maybe just like renumber them. So what this is going to do is you're going to have your variable n as the number of individuals in the data set. So n is going to equal 7 here, right? So we know there's 7 individuals here. This is a great way to do it. Next thing we're going to do when we're trying to calculate mean, median, mode for a data set, we're going to want to put this data set in numeric order. This is going to be really crucial for the first couple chapters to really do this. So you might want to rewrite your data set 5, 7, 9, 9, 12, 12, 13. Once again, always a great idea to recount your numbers. I can't tell you how many times people rewrite their data sets out and they're always missing a number. Make sure when you're doing this and you write it out, your n equals 7, you have 7 numbers. If you have 12 numbers and then when you write it out you only have 11, it's really going to mess up your 5-point summary. There's kind of no way around it, so just make sure you take your time and you put them in order. A lot of people, as they write them down, they'll write 5 and then cross out 5, then go 9, 9, and what ends up happening is they'll go 12, 12 or 7, and then they'll put the 12, 12 and they'll forget the 13, and it's right there and they didn't cross it off, and then when they go back they realize their mistakes. So you just always slow down, double check your work. So we know how many people we have. We've wrote them in order. So next thing we can do is we can find the median. So the median is going to be the middle value here. Since we have an odd data set, it's going to be our exact middle of the data set. So our median is going to be 9. Next, we can look at mode. When we have mode, we're trying to find out how many times a certain number pops up. So as you can see, we have 9, and it's popped up twice, and 12's popped up twice. So we'd write that the mode is 9 and 12. So it's bimodal. There's 2 sets of modes. If there wasn't a number that pops up more frequently than others, then we say there is no mode. Last, we're going to calculate the mean. Mean, also for a data set, is notated as x bar, so you'll see that a lot coming up. So what is the x bar? So x bar, the way we calculate mean is you sum sigma. You're going to sum up all the digits in your data set and then divide by the total number of individuals that are in that data set. So when you add up 5 plus 7 plus 9 plus 9 plus 12 plus 12 plus 13, you're going to get a value of 67. Divide by 7, that's how many numbers there are, and you're going to get 9.5714. Highly recommend getting used to going out 4 digits past the decimal spot. Please always go 4 digits past the decimal spot. I know a lot of classes have their different ways of doing things. 4 digits past the decimal spot, to me, is a great starting point. You can go more, but I would never go less unless there are not that many decimal spots to go, but always try to go at least 4 decimal spots past the for the answer. Go at least 4 decimal spots deep. So then we would say our mean, or x bar, is 9.5714. Okay, go back, let's see, calculate the mean, median, mode for data set. And there we go, calculate mean, median, mode for this data set. So here we go, here's number 6. The following values illustrate annual incomes among a group of households in a particular community. So here we have, the number of annual household incomes in this data set. So once again, it's not labeled, so one thing I would totally do is then now relabel this so we know exactly how many individuals or households we are dealing with. And we have 10, so n is going to equal 10. The number of individuals in the data set is 10, household is going to be 10. Okay, what is the mean, median, and mode of the distribution? Just like we did in the other one. So this one, if we're going to do mean and mode, then we're going to want to rewrite out our data set in order. So to make things a little simple, all these are in tens of thousands, if not hundreds of thousands. And instead of writing out $32,000, we can kind of simplify this, and 32 is going to be our first data point, right? And we have to understand these are all to the 10,000 or $100,000. But for writing them out and keeping things kind of organized, we can kind of simplify them here. 48, 62, 64, 72, 84, 92, 98, 187, and 295. All right, so there we go. There's our data set. Let's double check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N equals 10. Perfect. We have all our data sets included here. So now we're going to find we're going to do mode first, we're going to do median first. And since our data set is even, the way we find our mode is we're going to take your n plus 1 and then divide by 2. So if we were to do that, our n is 10 plus 1 equals 11, divided by 2 equals 5.5. That's where we find the median, right? Because it's not an odd number, so our median is going to fall in between certain values. Well, in between 5.5, since our numbers are labeled here, our median is going to fall in between these numbers. The way we find our median is we add up these 2 digits. So we're going to add up 72 plus 84. When we add them up and then divide by 2, you're going to get your value of your median there. So 72 plus 84 is 156. Divide that by 2, and you're going to get 78, which that is your median. Your median is 78. Next is going to be your mode. So as we look through our mode here, we see that no number occurs more frequently than itself. So we would say there is no mode. We'd say there's no mode, or it's unimodal. Unimodal. There's only one mode. Every digit itself is its own mode. And then lastly, we can go to our mean. Remember, our mean is going to be the sum of all the values divided by the total number. So when you sum up all the values that are present, so now remember, when you do this, if you just add up these values, right? If you just add them up like this, you're going to get a value of 103 or 1034. But remember, this has to be in. We have to multiply it by out and move our decimal three spots over to get the true value here. So just be careful when you do this for a mean. That we have to put them back into actual standard form. We divide this by 10, and you're going to equal it's 103.4, or the actual value itself would be 103,400. So just be careful when we do this. We have to make sure we move our decimal back to the right spot. So it's mean median mode. B, what is the relative frequency of households with an income over 100,000? So this one, a lot of times it trips people up. What we're looking for is what is the relative frequency? Frequency you can kind of think of as the percentage. What percentage of households have an income of over 100,000? So when we look at our data set over 100,000, there's only 2 households that really fit the bill there, right? Only those 2. So, and there's 10 total, so 2 of these households out of 10 fit the bill. We can reduce that down to 1/5, which is equal to 20%. Any one of these answers is correct. So that's the relative frequency. It's 1 out of 5, 2 out of 10, 20%. That is the frequency of households with over 100,000 annual income. All right, so I think we have time real quick to do number 7, and then we have to stop the video. So suppose that 6 individuals are interested in taking part in a study relating BMI to a number of health outcomes. The following 6 numbers represents the individual BMI. So we already know that there's 6 individuals here. Going a little quicker, you write them all out. Next thing you want to do is what is the mean and median of the individual's BMI. So if we're going to do a median, we have to write them all out in order. So it's going to be 18.96, comma, 21.06, 25.78, 29.51, 34.05, 36.54. Make sure we have them all. 3, 4, 5, 6, and equals 6. Perfect. So our median value, since we have an even number, is going to be your n plus 1 divided by 2. So you're going to take your 6 plus 1, 7 divided by 2 is 3.5. So our middle value, our median, is going to be between these two values. So you add them up. If you add these values up, you're going to get 55.29 divided by 2. Your median is going to be 27.64. Median. Next thing they want to know is the mean. So when we add all these up, take the sum of them, it's going to equal 165.9 divided by 6 equals 27.65. And as you can see, our mean and median are very close to each other. So we know this, if we were to chart this out, it'd be very potentially symmetrical. So part B, suppose that the BMI above 30 is considered obese. What is the relative frequency of the obese in this group? So we're looking at BMI above 30. So when we look down here, we have this value is above 30, this value is above 30. So we have 2 values over 6 are above 30, right? The frequency of it. We can write this down to 1/3, which is going to equal 33.3333%. Those aren't the best 3s in the world. And that is how you determine the relative frequency of the value here. All right, so that's going to conclude this video. I'll pick up and do numbers 8 and forward in the next video.